Hi everybody, today I'm going to take you through an ESQL observability demo. In today's digital world, businesses are generating an unprecedented amount of data. This data holds valuable insights that can drive business decisions, improve customer experiences, and optimize operations. However, extracting these insights from complex distributed systems can be challenging. Traditional methods of data analysis can be time-consuming and require specialized knowledge, making it difficult for businesses to react to changes in their systems or customer behavior. This can lead to missed opportunities and slower decision-making processes. Elastic Observability, with its new pipe-based query language, is designed to address these challenges. It simplifies the process of querying complex, distributed data, making it easier for businesses to extract valuable insights from their systems. The new ESQL query language delivers advanced search capabilities with concurrent processing, improving speed and efficiency irrespective of data source and structure. Accelerate resolution by creating aggregations and visualizations from one screen, delivering an uninterrupted workflow. So let's take a look at ESQL. Over here in Discover, you can see we've got this new ESQL in the drop-down box in the top left. Broadly speaking, ESQL is a pipe query language which allows users to process streams of data by chaining together a series of operations or commands, where the output of one command becomes the input to the next. So let's take a little look at what a more advanced query might look like. I want to show a list of services with APM data. My data is in the traces APM index, and I want to show the average transaction duration, the success rate, and the total number of requests. So let's take a look at a query that I've prepared here. As you can see, what we're doing here is we're taking data from this source index. The data source is what is defined in the from command. Any indices that matches the traces APM star pattern will be included in this query. Once we have all of that data, all that source data, we then essentially limit the amount of data that comes back to what has occurred within the last 24 hours. We then pipe the data to a further command, the eval command, which creates two new columns, a successful column, which will be 1 if the event outcome is a success, and a failed column that will be 1 if the event outcome is a failure. We then pipe the data through to the next part of the query, which is to do a stats calculation, right? So here we're actually creating 3 new columns: success rate, average duration, and total requests. The success rate is the average of the successful column, which gives us the proportion of successful events. The average duration is the average of the transaction duration field, which gives us the average transaction duration in microseconds. The total requests is the count of the transaction ID field, which gives us the total number of requests. So if we run this, we'll see that we get an overview. Oh, actually, notice that was very, very fast. So ESQL is much, much faster than what we would traditionally have got with the original query endpoint in Elasticsearch. So you'll notice that there's a much better speed and you'll get faster time to insights from this new query language. So as you can see here, we've got the service name, the total number of requests, the average duration for each service, and the success rate of this particular service. So the ad service is not doing too well. So what we've seen here is we've looked at how we can get APM data. We've looked at how we can use that data to calculate a success rate and an average duration. But we also want to be able to get other observability data like log data. So let's take a little look at a query I prepared here, which contains analysis from log files. So we've got Kubernetes logs here that we're looking at. And what we're trying to do is we're looking at Python pods that are running in Kubernetes. We then only want messages where there's a HTTP, something in the logs that has HTTP in it, so that we're restricting it to just HTTP messages. we're then taking those log lines and extracting the HTTP code. And this is useful so that we can see if there's been any errors. So let's have a look. So no, actually our Python services here in Kubernetes seem to be doing pretty well, since we only seem to have HTTP 200 error codes, which is absolutely fantastic. That's what we want. So now we've seen APM and logs data and how we can analyze that. We'll see in here in the logs one in particular that we can use Grok, which is super nice. We can actually use regex. So if we've got unstructured data in Elastic, we can actually start to give it some structure through ESQL, which is super handy when you think about in the past, you might have to have done this through Logstash or ingest pipelines. We could do this very, very quickly now with ESQL. So that's the Discover console, but we also have another really great thing that we can do with ESQL. If we go over here, we can actually use the Elastic AI Assistant in conjunction with ESQL to actually convert natural language into ESQL queries, which is really great if you're you're not a technical person and you have no idea about query languages. You really will get a lot of value out of using the AI assistant to do this. So let's take a look at something I prepared here where I want to just check the APM data and get the average transaction duration per service over the last hour. And as you can see, I haven't had to use any technical language in here. And if I ask the AI assistant to help me, it will generate an ESQL query for me by automatically going back to Elastic and using a particular function that we've created in our API to allow us to do that. Then the Elastic Assistant is going to break down step by step what needs to happen in this query. And then we can run the query directly from this interface, and the Elastic AI Assistant will do some analysis and present that for us. So I think with ESQL, businesses can write more efficient queries, access and analyze their data more easily, gain insights faster. They can use ESQL directly in Kibana or leverage the Elastic AI Assistant to generate ESQL queries, making data analysis accessible to a much wider range of users. The benefits of using ESQL and Elastic Observability are clear. Businesses can leverage their data more effectively, make data-driven decisions more quickly, and democratize access to data insights across their organization. This leads to improved operational efficiency, better customer experiences, and a competitive edge in the market. I hope you enjoyed this demo. Thank you very much, everybody.